greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed on horizontal temperature distribution. In this lecture, we will be discussing on vertical temperature distribution. So, what are all the contents we are going to discuss in this lecture? That is the change in temperature with altitudes and how the temperature decreases in troposphere and increase or stabilizes in higher layers, the control which have been controlled by radiation, pressure and gases, and how far it influences the weather, cloud, aviation and climate. So, what is meant by the vertical temperature distribution? The vertical temperature distribution describes how temperature changes with altitude. So, please recall the previous session, that is the layers of atmosphere, how the thermal activity, that is temperature distribution, have been distributed in the layers of atmosphere. So, the diagram is here, it has a sigma pattern of temperature distribution. So, in the atmosphere layers, so you can see that the troposphere have the decreasing temperature distribution, and then there is a pass and there is a rise and there is a pass and there is a decrease. So, in such a way there is a zigzag pattern of temperature distribution in the atmospheric layers. So, that will be explained in the section. It is observed that from the Earth's surface to the thermosphere. So, we have the thermosphere here. So, from the Earth's surface till the thermosphere, how the temperature have been distributed. So, that will be the vertical temperature distribution of the Earth's surface. How far there is a temperature variation is uneven across the atmospheric layers. So, see in this diagram, is it even? No, it is a rise and fall and rise. So, that zigzag pattern is witnessed in this diagram, that is the vertical temperature distribution. It have been controlled by various factors. What are all the factors which are controlling this rise and fall? That is absorption, reflection and emission of radiation. So, these are all the processes which activate the temperature in these atmospheric layers. The atmospheric composition and density influences the heating and cooling of the atmosphere. And the vertical structure is most fundamental for what? That is the weather and then stability and climate. So, all these processes are dealt with the vertical temperature distribution. The first and foremost is troposphere. Though we all know that the troposphere is the lowermost layer. So, that is the lowest layer of the atmosphere. It is very much close to the Earth's surface. The temperature decreases with the height. So, this is the normal lapse rate. So, when you go high, what happens? Automatically the temperature will decrease. Why there is a decrease in the temperature? Because of pressure. So, that relationship will be studied in this vertical distribution of temperature. That is, the temperature decrease with height in what normal lapse rate? That is 6.5 degrees Celsius per kilometer. And almost all the weather phenomena will be carried out, all the weather process will be held in which layer? That is troposphere. What are all the weather phenomena? The cloud formation, rain and storm occurs in this layer, that is troposphere. Its thickness varies with the latitude. So, in that lecture also we have discussed about the various of the thickness of each and every latitudes, that is it is thicker in equator and thinner in poles. So, this variation is there in the troposphere. It contains most of the atmospheric gases which supports all the forms of life. So, because of these entire weather processes and other activities which have been carried in the troposphere, which is much support for the life forms of the Earth's surface. The tropospheric lapse rate. So, this lapse rate is most important. So, this average temperature decreases 6.5 degrees Celsius per kilometer. So, while you climb up, that is the higher altitude, there is a 6.5 degree Celsius decrease of temperature when the altitude is increased. It is also known as normal lapse rate, which will be prevailing in troposphere. It is caused mainly by decreasing air pressure. So, we have discussed earlier that this action is mainly because of pressure, air pressure. It is not a constant everywhere. So, make a note of it, it is not constant, this is not constant. There is a reversal activity of this is also going to happen, that is the temperature inversion, which we will be discussing in the next lecture, temperature inversion. So, this it is not constant everywhere or at all times, it is not constant in all times, it is not constant in all places. So, this is a main catch here. It is measured using radio zones during the atmospheric observations. The measuring will be done by the radio zone sounds. Environmental lapse rate, that is we call it as ELR. That is, it is actually actual temperature decrease measured in the atmosphere. The ELR is also the temperature decrease in the atmosphere. It varies hourly and seasonally with weather condition. So, according to the weather condition, it decreases. It depends strongly on the surface heating and cooling. So, how far the surface is, how the heating and cooling process have taken place in the earth's surface, based on that this process will be happening. It is very important for the atmospheric stability and instability. So, the atmospheric stability and instability is also one of the major concept in the climatology. The temperature inversion. So, what we have discussed in the normal lapse rate, that is it will be in a orderly way, but not in all place or all time. Here there is a reversal activity in the temperature inversion. What reversal activity? That is, the temperature inversion is a reversal of normal lapse rate. Instead of cooling, the temperature increases with altitude. So, here if you go up, what happens? The temperature, instead of lowering, what happens? It will be increasing. So, this is the process of this temperature inversion. So, it occurs commonly during what is the favorable conditions for this process is the clear nights and winter season. So, clear nights and winter season which supports this kind of process, that is temperature inversion. It also creates the stable air which traps the pollutants and moisture near the surface. See here in the diagram, so there is a pollution. So, because of this pollution, what happened? This warm air, instead of going up, what happens? It have been constantly stay back in nearby the earth surface. It acts as a trap, it acts as a shield. So, it does not allow the cold air going up to the higher levels, higher layers of atmosphere. So, this trap, which is a warmer air present here, makes the temperature inversion. The vertical air mixing. So, because of this trap, what happens? The vertical mixing is suppressed. So, it is suppressed in this layer itself. So, this suppression is there in this particular layer, and it affects, because of the suppression, what happens? It affects the weather and air quality. So, this is the main characteristics of temperature inversion. So, the next is tropopass, that is how far in tropopass the thermal characteristics are there. So, the tropopass is the layer which is above the troposphere and then below the stratosphere, that is the tropopass. The name itself, you have the pass here, that is some stopping activity is done here in between the troposphere and stratosphere. It acts as a boundary between the troposphere and stratosphere. At this level, the temperature stops the decreasing with height. So, till here what happened? There was a temperature decrease, but here what happens? It stopped. Okay, the decrease stopped in the tropopass. The height varies with the latitudes, the higher at that is higher at the equator and lower at the polar region. So, this was the height of the tropopause, and the jet stream, the main weather event, that is jet stream, are commonly found near this layer. So, because of this decrease and that air pressure, so this jet stream is most commonly found in this tropopause, that is troposphere layer. It acts as a barrier limit of the vertical mixing of air masses. So, it was a barrier limit. So, here is a bar for the troposphere as well as the stratosphere. So, it acts as a bar. So, which is that? That is tropopause. The next is this stratosphere, the second layer of the atmosphere, where there is a increase in the temperature. The temperature is increasing with the height. So, due to what? Why there is an increase in this layer? Because of ozone absorption of ultraviolet radiation. If there is any absorption, it may be a dust or it may be a polluted particles or other PM particles. What happens? That characteristics will change. It absorbs all the dust particles and it won't allow the air masses to enter away from the region, that is from that layer. So, this is the main reason that the stratosphere is most heated, that is it has a high temperature. The presence of ozone layer causes the warming in this layer. So, this layer stratosphere is very warm in nature, the atmosphere is stable. So, it is very stable. So, because of the stable condition, what happens? The flights, it supports the aviation, that is flights to pass away from this layer. It provides the ideal flying condition for the jet aircrafts. The aircrafts can fly in this layer. It shows a very little vertical mixing. So, in this layer there is a very little mixing happens in stratosphere. The next one is the stratopause. The stratopause is the boundary between the stratosphere as well as the mesosphere. So, this is a next boundary, that is a second layer boundary. It is the upper boundary of stratosphere. The temperature reaches its maximum. So, here the temperature is high when we rises, when the altitude rises. Because of ozone absorption, the air is thin but varies in stable condition, and it serves as a transition zone to mesosphere. The next layer of atmosphere is mesosphere. So, it is a transition zone. The stratopause is the transition zone between stratosphere and mesosphere. It plays indirect role in UV radiation filtration through the stratosphere. Because of this, there is a increase in temperature in this layer. Next one is mesosphere. How the temperature pattern will be there in the mesosphere? The temperature again decreases. So, decreases with the height. It is unlike the stratosphere, the temperature was decreasing. It is the coldest atmospheric layer. So, it has minus 90 degrees Celsius. So, in that lecture we have discussed the same point. It also experiences strong horizontal winds and atmospheric waves. So, all these process happens in the mesosphere. The most meteors burn up. So, meteors burn up activity is carried out in this mesosphere. Because of what? Because of friction. Because of friction, this process happening, the meteors will burn. The air pressure is extremely low here because it varies in the thin air. It varies with the thin air. Next one is mesopause. So, mesopause is the boundary of the mesosphere. So, in this mesosphere, the already we have discussed, that is the minus 90 degrees Celsius will be the temperature. See, imagine how cold this mesosphere, that is especially the till mesopause, how cold the temperature is. It marks the boundary between the mesosphere and the next layer, that is thermosphere. It is located very high, it is located in very high altitudes where the atmospheric waves are common in this layer. It represents a distinct thermal minimum. The temperature is very minimum because when we go vertically, it is the coldest region of atmosphere. So, while we consider all the layers, the much colder region is the mesosphere, that is till mesopause. Next one is thermosphere. The thermosphere temperature pattern is, again the temperature is increasing sharply. So, with altitude, due to the absorption of high energy radiation. So, if the altitude is going to be high, it is somewhat nearby the influence of sun, the solar radiation is absorbed directly. So, because of that, this heat energy is created, the temperature is very high. It contains the ionosphere, and it is also important for the radio communication. So, the communication activities are carried out in the ionosphere layers. The air is extremely thin and low in density in this thermosphere. This region have auroras. So, the colorful lights, that is northern and southern lights, aurora borealis, aurora australis, all these occurs in this thermosphere. And it also observes the X-rays and ultraviolet radiations from the sun. Next one is the ionosphere heating. It is formed by the ionization of atmospheric gases under intense solar radiation. Because of solar radiation, all this heating process happens in these layers. It contains very rich free electrons and positively charged ions are there, and it plays a crucial role in reflecting and refracting radio waves. The radio waves are reflected and refracted in this region, which is very much helpful for the communication process. It exhibits the strong diurnal variation, so being more ionized during daytime. So, this activity is very much active in daytime. Lies mainly within the thermosphere at very high altitudes. Exosphere, the last layer of the atmosphere. Now, how the temperature will be? It is the outermost and extremely thin layer of the atmosphere. In the exosphere, that is the gas molecules move at very high speeds. This is mainly because of minimum gravitational control. It gradually merges to the outer space. So, here it will be merging to the outer space. So, there is no clear upper boundary for this exosphere, and it consists of that is the concept of temperature becomes ambiguous. So, there is no clear cut temperature pattern for this layer. Because of sparse particles. So, a lot of particles, sparse particles will be there in this layer. So, that is the main thing for the ambiguity. It composed mainly of the light gases such as hydrogen and helium. In the atmospheric evolution, we have come across the composition of atmosphere, where the initial stage, the hydrogen and helium was the major gases found in the atmosphere. Thus, that concept will be there in this exosphere. What are all the factors which affects the vertical temperature? They are adiabatic processes, surface heating, atmospheric composition, clouds, and then solar radiation. So, these are all the major factor which affects the vertical temperature. What is meant by adiabatic process? That is, it occurs with no heat exchange between air and its surrounding. So, it does not allow anything inside or outside. So, this is the one parcel, one box. So, there will not be any heat exchange in this region. And the rising of air expands and cool due to what? That is decreasing pressure. Because of decreasing pressure, there is a rise of air expand and cooling process happens. This is also known as expansion cooling. And then if the air sinks, if the air rises, it is the expansion cooling. If the air sinks, what happens? It compresses and warms due to increasing pressure. Here decreasing pressure, here in the sinking air it is a increasing pressure, and it is known as compression heating. Here it is expansion cooling, here it is a compression heating. It plays an important role in the cloud formation, and as a cooling leads to the condensation, that is latent heat, the hidden heat which is present in this air molecules, which is supportive to the formation of clouds. It drives the convection and vertical air movement in the atmosphere. So, this is the main concept of what? Adiabatic process. This adiabatic process have been classified into two, that is dry adiabatic lapse rate, that it called as DALR. So, if it is in short form, you please make a note that it is a dry adiabatic lapse rate. In the dry adiabatic lapse rate, the temperature falls. The dry, it is a hint here that there is a fall in temperature at the constant rate, that is of 9.8 degree Celsius per kilometer when it ascends. It applies to dry unsaturated air and where there is no condensation occurs. So, because there is no water content here, without water content, how the condensation and cloud formation will be happening in this region? So, it is in dry adiabatic lapse rate, there is no condensation occurs. The cooling is caused mainly by the adiabatic expansion due to the decreasing pressure. The relationship will be between pressure and temperature. So, this is the main thing you have to keep in your mind in this concept. So, because of no latent heat latent heat is released, the cooling is rapid and uniform. The cooling is very uniform in this DALR. This DALR is greater than the environmental lapse rate and the wet adiabatic lapse rate. So, this dry adiabatic lapse rate is greater than the ELR and the wet adiabatic lapse rate. So, this is the main thing you have to keep in your mind regarding DALR. Next one is wet adiabatic lapse rate. So, wet here represent the some moisture content will be there in this adiabatic lapse rate. The temperature here, because of moisture content, temperature will be decreasing. Temperature here decreases at variable rate, that is 4 to 7 degrees Celsius per kilometer. It is applied to saturated air masses. The air masses are saturated here after the condensation process. The latent heat is present inside this air parcels. So, because of that, the condensation happening in this process. It results in slower cooling compared to the dry adiabatic lapse rate. So, there it is because of dry nature, the rapid cooling happen. So, here it is it has a water moisture content inside. So, there is a slow cooling process happens in this WALR, that is wet adiabatic lapse rate. It encourages a continued lifting, cloud growth and precipitation. So, this is the driving force for the formation of cloud and uplifting of air and then growth of cloud and precipitation. The rainfall is mainly due to this wet adiabatic lapse rate. Atmospheric stability. The stability is most important. It is determined by comparing the lapse rates. So, how it is? It have the stable air, unstable air and neutral stability. In the stable air, it is suppressed. It is suppressed vertical motion. Vertical motion is not allowed here. It is suppressed in this region itself. So, it limits the growth of the clouds. So, here see you have the clouds only in the limited space, in the limited altitude. In the unstable air, it promotes the convection and rising current. So, it also supports what? The growth of clouds. Here in the neutral stability, it occurs when the lapse rate is equal. Neutral means equal, lapse rate is equal. The stability condition strongly influence what? The stability. If it is stable nature, if it is unstable nature, that it directly influences the thunderstorm development. So, thunderstorm occurs because of the stability and instability condition of the atmosphere. Next one is the stability condition. The stable atmosphere, that is environmental lapse rate ELR, is lower than DALR means dry adiabatic lapse rate and WALR means wet adiabatic lapse rate. So, this ELR is lower than this two. So, when this condition prevails, that is a stable atmospheric condition will be there. If it is going to be an unstable atmosphere, that is ELR exceeds the DALR, that is dry adiabatic lapse rate, which allowing the air parcels to rise freely. So, it is allowing the air to move forward. The conditionally unstable atmosphere, that is conditionally. So, this is most important. The conditionally unstable atmosphere, what happens? That is ELR, that is environmental lapse rate, lies in between, that is between DALR and WALR, that is dry and wet adiabatic lapse rate. So, it is the in between condition. The air becomes unstable only after saturation. After it reaches the saturation point, this condition will prevail. The knowledge of stability is very much important. Why it is very much important? It is important for the aviation. So, aviation is mainly dependent on atmospheric processes, mainly the stable condition, and so by seeing this only, the aircraft will be take off and landing process will be done. The stability analysis helps the forecast cloud formation, vertical mixing and thunderstorms. So, these processes happening because of stability condition. The temperature profile in daytime. So, how the temperature will be in day? That is strong surface heating. We know that incoming solar radiation will be constant in the daytime. So, there will be a strong surface temperature which creates a very steep temperature gradients. And then the temperature decrease rapidly. How far it is increasing the temperature? The same way it decreases the temperature also in a speed manner, rapid manner, which producing this steep lapse rate. These condition leads to high atmospheric instability. Because of this rising and again cooling, heating, cooling. So, this process leads to high atmospheric instability. The intense convection develops, the warm air rises rapidly. Because of this convection activity, the warm air rises rapidly, which results in cumulus clouds formation. So, clouds are formed because of this process. And also the cumulus and this cumulonimbus clouds is forms because of this process in the daytime. What happens in the night time? That is, the surface is cooling. They are heating in the daytime. Here cooling leads to development of temperature inversion. Again here there is an inversion. The inversion formation creates the stable atmospheric condition. In the daytime, unstable condition forms the clouds. In the night time, it is a stable condition of atmosphere. The vertical air movement suppressed, again here it is restricting, the air movement is restricted in this part and keep the atmosphere very calm. The wind are generally light and calm near the surface region. In such condition, what happens? The formation of fogs and frost. So, in the ground layer, because of not allowing the air movement, this fog and frost is the main process formed in this night time. Mountain and valley influence. How the mountain and valley influences the vertical temperature distribution? That is, cold air drainage causes the dense cool air flows down slope in night. So, night what happens? The cool air flows towards the that is down slopes at the night time. It leads to valley inversion with that cold air trapping at the valley floors. So, in the valley floors, what happens? The air, cold air is trapped here, and as a result what happens? The temperature increases with the height. The temperature increases. What to be done? If it is going to be temperature increases with the height, it is a inversion of temperature happens in this region. And the differential slope heating, that is the windward side and the leeward side, where here there is a active precipitation, this side very dry condition. So, all this process leads to the orographic effect, which modifies the airflow stability and also local climate of that particular valley and mountain region. Urban effects on the vertical temperature. So, in the urban region, what are all the important thing happening? That is the urban heat island. So, because of the human influence, there is a pollution. So, pollution, and because of pollution, the suspended particles will be there in the atmosphere. Again, the inversion happens in that particular urban places, which rises the heat in that urban place. So, this leads to urban heat island effect. In the night time, the heat retention delays, and that is, and there is a reduce in the inversion breakup. There is a breakup of the inversion. So, these conditions leads what? In the night times there will be a severe cold condition. So during the daytime there is a intense heating, and it's because of enhances the convection and instability of that particular place. The pollutants and aerosols modifies the lapse rate of that urban areas, which is affected by the radiation balance. Overall, urban heat islands alters the local thermal structure and as well as the atmospheric stability of that particular urban region. Vertical temperature and weather. How the weather and vertical temperature is related? That is, it helps to predict the likelihood of intensity of rainfall. How the rainfall pattern is there is affected by the vertical temperature. It also indicates the potential for the thunderstorm development. So, in the previous slide we have explained in detail about the thunderstorm development, and it also determines the height and type of the cloud formation. So, what are all the factors which leads to the cloud formation? So, this is mainly because of vertical temperature. It also influences the wind shears, that is a sudden change of the velocity of wind. The turbulence condition also occurs in the vertical because of the differential vertical temperature. It also controls the behavior and movement of air masses. So, because of all these weather phenomena, it adversely affect the local or micro level climate and then the climate of the world. Seasonal variation and vertical temperature, that is, in summer season there is a strong lapse rate due to the intense surface heating and convection. So, this is the main convection is the main one, that is heating process is the main process which leads to the strong lapse rate in the summer season, and in the winter season it is vice versa, that is it experiences stronger and frequent inversion is experienced here because of long night and radiation cooling. So, this process leads to the strong frequent inversion in the temperature during winter season. The seasonal change in solar angle also affect this vertical temperature, which controls the amount of surface heating, and cloud cover which plays a vital role. So, this is one of the major factor which affects the vertical temperature of that particular region. Next one is the land and water contrast. So, we know that in previous lectures there is a contrastivity in the receiving heat and then emitting back the heat radiation. So, because of that contrast there is a vertical temperature differences in that particular place. Role of atmospheric process. How the atmospheric process plays a vital role in vertical temperature distribution? It controls the cloud formation, which regulates the air uplift and condensation. So, a condensation, air uplift, all these processes are controlled because of what? The vertical temperature distribution. It determines the atmospheric stability and instability. So, that condition is also main for the vertical temperature, which leads to the vertical temperature variation. It influences the air movement, that is the convection and then vertical mixing. All these processes highly affect or highly influence the atmospheric processes. Directly it affects the precipitation type and then intensity of the precipitation. It also plays an important role in shaping of the climatic zones. So, all the global climatic zone is mainly because of this vertical temperature distribution. Importance for aviation. So, in aviation it plays a vital role. It determines the safe and efficient flight paths at the different altitudes. So, the pilot should have an clear cut idea about this atmospheric stability, what is that instability of atmosphere. So, this is most important. It influences the occurrence of turbulence and then wind shears. So, this turbulence, wind shears will be there in the atmospheric process. So, that should be understood by the pilots. It also helps in predicting the icing condition within the clouds, and it assists the meteorological planning and weather forecasting. So, this two major thing can be done with the help of the understanding of vertical temperature distribution concept. To sum up with the entire content, that is, the vertical temperature distribution refers to change in temperature with altitude in the atmosphere. That is, the temperature generally decreases with the height in the troposphere. In the troposphere, this was the condition, while in the higher layers, either it may be increasing or it remains the stable condition due to the variation of radiation absorption and atmospheric composition. This distribution is mainly controlled by solar radiation, air pressure, and the presence of different gases. It plays a vital role in shaping the weather processes, cloud formation, and aviation condition, overall the climatic pattern. Hope you all understand this concept, that is vertical temperature distribution. In the upcoming lecture, we will be discussing the temperature inversion. Thank you.